Good morning, everyone. Today's topic is scales and sludges. So today we are going to see the definition of the scales, sludges, and then causing salts, disadvantages, at the same time, how to prevent these scales that we are going to discuss in today's class. So first we'll get into these sludges. So what is a sludge? Sludge is nothing but a soft, loose, slimy precipitate which is formed inside the boiler material. And the salts which are responsible for the formation of these sludges are magnesium carbonate, magnesium chloride, magnesium sulfate, calcium chloride. These are the salts which are responsible for the formation of these loose, soft, slimy precipitates which are formed inside the boiler material. So generally these sludges are formed at the colder parts of the boiler material, and they will collect at the places, and then where the rate of flow which is going to be decreased because of the formation of these sludges inside it. So how can we define a sludge? Is nothing but it is the sludges are the soft, loose, slimy precipitates formed inside the boiler material when we are boiling the water for the production of the steam. Okay, so generally you can see this diagram here. Okay, how the sludge it is present inside the water. We can see this the loose precipitate which are suspended in the water. These are called as a sludge here. So inside the boiler material, whatever the water that we are considering there, that is the boiler feed water, right, for the production of the steam, right, we are going to observe these slimy loose precipitates inside the boiler material. Yeah, right. So then how to prevent this such type of sludges which are formed inside the boiler material? One is by considering the softened water. Instead of using the hard water, if you consider softened water, so the dissolved salts are going to be absent in case of that. The permanent hardness causing or the temporary hardness causing salts are going to be absent in case of the soft water. Then we can prevent this sludge formation. And the second method is by frequent blowdown operation. So what is this frequent blowdown operation? Drawing out the portion of a concentrated water from the boiler and considering the new water, considering the fresh water. So like this, by blowdown operation, we can remove these sludge materials, sludge particles which are formed inside the boiler material. Then what are the disadvantages that are going to take place that are causing this boiler material means? These sludges are going to act as a poor conductor of heat. If you heat the means when you're for the production of the steam, if you heat, okay, whatever the sludge like material which are present there, slowly, when for long period of time, these precipitates, if they're present inside the water, if they get settled at the bottom, slowly, okay, when its concentration increases, they will be converted into scales also. Another scales are they are the hard adherent precipitates, but this sludges, if you consider, they are going to be the loose, slimy precipitates. Okay, by blowdown operation, we can very easily. But if they form the scale, then again they are going to get firm, get stick to the boiler material hardly. So then to remove them, it is very difficult when compared to the sludge. So these sludges, it should be removed by making use of this blowdown operation here, or by considering the softened water, we can prevent this particular the sludge formation here. So the disadvantages we consider, they are going to act as a poor conductors of heat. Okay, and if excess sludge, if excess precipitates, if they're forming inside the boiler material, then it is going to affect the working of the boiler material. Means working condition of the boiler can be decreased, okay, because of the formation of the excess sludge also. Right, not only that, it is going to decrease the efficiency of the boiler also. At the colder parts, at the joints, okay, at the plug openings there, if the sludges, if they're getting stick to that, right, it will slowly damage the boiler material also. So what is sludgy is nothing but it's a soft, loose, slimy precipitates which are formed inside the boiler material. Inside the water, we are going to absorb these precipitates, right? Whereas if you see the scales are going to be the hard, sticky, okay, adherent precipitates. Okay, in the diagram, if you see here, okay, in this, the scales they are formed along the inner walls of the boiler material. They are formed at the inner walls of the boiler material. So the difference between the scale and sludge is this one. These are formed along the inner walls, whereas sludges are formed inside the water as a precipitate, as a soft precipitate, as a finely divided particles. The sludges are forming, but the scales are the precipitates which are formed along the inner walls of the boiler materials. They are the hard, sticky, adherent precipitates that are formed along the inner walls of the boiler material. You can see the diagram here. The scales are nothing but they are present as a layer. It is present inside the boiler material. Right? Then what are the causes for this? Which substances are responsible for the formation of the scales? The first one, decomposition of the calcium carbonate. Okay, decomposition of the calcium, the bicarbonate, if you consider, okay, the calcium bicarbonate, we gives the calcium carbonate, okay, plus carbon dioxide and then water. So here the decomposition of the calcium bicarbonate is responsible for the, means the calcium bicarbonate, when it is giving the calcium carbonate, okay, it is responsible for the scale here. Means the scale forming substance is calcium carbonate here. So when the calcium bicarbonate, when it decompose, calcium bicarbonate, when it decompose, then it is going to form this calcium carbonate. So calcium carbonate, okay, it is responsible for these scales here. Okay. And then the deposition of the calcium sulfate. The calcium sulfate is a permanent hardness causing salt. Calcium bicarbonate is a temporary hardness causing salt. Even the permanent hardness causing calcium sulfate, if it is present inside the water, and it is going to get precipitate as the hard sticky precipitate here, okay, along the inner walls of the boiler material. That too, on the hot portions of the boiler, we are going to observe these scales. Okay, for this scale, the calcium sulfate also, it is going to play an important role here. So calcium bicarbonate, when it gives the calcium carbonate, right, this calcium carbonate is going to form a scale-like substance, scale-like layer, okay, and then calcium sulfate, the permanent hardness causing salt, also it is responsible for the formation of hard, adherent, sticky precipitate along the inner walls of the boiler material. Even the magnesium salts, if we consider, the magnesium salts, when they undergo the hydrolysis, they are going to form the magnesium hydroxide. A soft scale-like substance is going to form when the magnesium chloride, which is a permanent hardness causing salt, when it is undergoing the hydrolysis process, it is forming the magnesium hydroxide. Even the magnesium hydroxide also, it is a soft scale forming substance here, right? And not only that, even the calcium and the magnesium silicates, that too is very small in quantity. These the calcium or the magnesium silicates, okay, if they are present, means they are responsible for the formation of the scales also. Generally, the calcium and the magnesium silicates now, they are not, by default, they are not present inside the water. Okay, if the silicates like silicon dioxide, SiO2, when they combine with the calcium or the magnesium, we are going to get the calcium silicate, that is CaSiO3. Okay, at the same time MgSiO3. Calcium silicate and the magnesium silicates are forming. These silicates, the calcium and the magnesium silicates, they are responsible for the formation of the scales along the inner walls of the boiler material. So the what are the salts that are responsible for the scales are nothing but the calcium carbonate, which is formed because of the decomposition of the calcium bicarbonate. Okay, calcium sulfate, which is a permanent hardness causing salt, it is also a salt which is responsible for the formation of scale. At the same time, the magnesium salts like magnesium chloride, a permanent hardness causing salt, when it undergoes the hydrolysis, it is forming magnesium hydroxide, which is a soft scale forming substance here. At the same time, the silicates, when they combine with the calcium or the magnesium, the metal ions inside the water, they are going to form the calcium silicate and the magnesium silicate. That is CaSiO3 and then MgSiO3. So these four substances are responsible for the formation of the hard, sticky, adherent precipitates along the inner walls of the boiler. Okay, so then what are the disadvantages of this scales? The scales, if they're formed along the inner walls of the boiler material, then what will happen? Right, generally the wastage of fuel. Wastage of fuel takes place if the scales are formed along the inner walls of the boiler. Excess the fuel consumption, it is going to take place. We have to heat more, we have to supply more heat for boiling the water for the production of the steam. So excess fuel consumption will take place, which results in the wastage of the fuel here. And not only that, if the scales are formed along the inner walls of the boiler material, it is going to lower the boiler safety also. It will decreases the efficiency, and even it leads to the explosion of the boiler material also. So these are certain the disadvantages if the scales are formed along the inner walls of the boiler material. That is wastage of the fuel, lowering of the boiler safety, decrease in the efficiency, and danger of explosion. These are the four important disadvantages if the scales are formed inside the boiler material. Then how to remove this? Then how to remove the scales which if they are formed along the inner walls of the boiler material? Suppose if they loose or is somewhat soft scales, if they are formed along the inner walls of the boiler material, we can remove them with the help of a scraper or with the help of a wire brush or by blow-on operation. Means if the scales are soft, then we can remove them by scraper or by wire brush, or if not by blow-down operation, we can remove them. Suppose if the scales are hard, they got stick to the boiler material very hardly, very firmly, then you have to go for the chemical treatment. We can use the 5% HCl, dilute acid we can use. The same time we can wash that, okay, with the help of the EDTA, ethylene diamine tetraacetic acid. Okay, so if they are hard and if they are if they're forming a sticky layer along the inner walls of the boiler materials, we have to choose the chemical method. If they are soft means, then we can easily remove them by scrapers or the by brushes or by blow down operation. Suppose if the scales are brittle, then we can remove them by hammer shocks. Okay, so one is by scrapers, the scales are soft, by scrapers we can remove them, or by wire brushes we can remove them, or by blow down operation we can remove the soft scales. The scales are brittle, then we have to go for the thermal shocks, right? And if the scales are very hard, because even sludges are also they're forming the scales here. Sludges also, okay, for long period of time, they're getting settled at the layer, and if it is not properly maintained, the sludges also will be converted to a hard sticky precipitate here, right? So if the hard and the adherent scales, if they are present, means by we can remove them by dissolving with suitable chemical substances like 5% HCl or by using EDTA. Okay, we can remove the scale forming substance of the scales which are formed along the inner walls of the boiler. Right, these are the removal of the scales. Okay, fine. Then how to prevent this scale? Simply by considering the softened water, instead of considering the hard water, instead of considering the magnesium salts inside the water, instead of considering the calcium bicarbonate inside the water, instead of considering even the very small quantity of the silicates, okay, if we avoid that, then we can over magnesium chloride, calcium sulfate, calcium carbonate, or this calcium silicate or the magnesium silicate. If these salts are absent inside the water, then we can overcome this. Means by using softened water, we can overcome this process. So scales can be prevented by using softened water. Even the sludges also can be prevented by using the softened water, right? So this is about the formation of the scales, okay, the disadvantages, formation, and then prevention. Okay, thank you. So thank you for listening to my class.